So the Nobel Prize in Chemistry this year goes for the determination of the high-resolution structure of the ribosome. The ribosome is a large and very elegant machine which translates information from the nucleic acid world, from DNA and RNA, actually from RNA, into protein. The structure is incredibly complicated with several large pieces of RNA and 40 some odd proteins and literally millions of atoms. It's it and RNA polymerase, which was recognized from the Nobel Prize a few years ago, are among the most complicated structures that have been solved. The structure of the ribosome is important for three reasons. First off, it's just an incredibly fundamental process in biology. Understanding how proteins are synthesized is, we really can't claim to understand biology at all unless we understand that process in considerable detail and how it's regulated and so on. Secondly, from an evolutionary perspective, the ribosome is very important, and there's a chicken and the egg problem, and that is, if ribosomes are essential for making proteins, but proteins were essential components of the ribosome, then how did things get started? So when the structure of the ribosome was solved, one of the things that was clear was the active core around where the peptide bonds proteins are actually synthesized is all RNA, that the proteins are off around the edges and are really playing much more accessory roles. So it's consistent with the hypothesis that there was an RNA-based machine that eventually developed the ability to make proteins, and then proteins took over that and then many other functions. So it was very gratifying from the point of view of understanding, or at least developing a richer hypothesis about the RNA world. And the third is more practical and applied, and that is, because it's so important for life, there are ways of gumming up ribosomes. So some antibiotics function because they will bind to and block the function of bacterial ribosomes, but our ribosomes are different enough that they don't bother ours. And now with the structures available, there's a lot of interest in trying to use that structural information to develop new antibiotics, either refine existing ones or develop new antibiotic strategies based on the differences. What I think this prize recognizes is both the courage to tackle a problem of this importance, and then the technical developments all along the way, from the biochemistry through synchrotron radiation sources, through the computational methods and everything else, to bring it all together and really get to the point of getting these deep biological and chemical insights.